This video will be about the normal distribution. So before we look at normal distributions, let's see what a frequency table is. A frequency table lists all of the numeric outcomes of an event and their corresponding frequencies. So for example, if I went through a class trying to figure out the heights of every student, I can construct a frequency table based on the data. So I could make a range like 4 feet to 4.5 feet, 4.5 to 5, 5 to 5.5, 5.5 to 6, and 6 to 6.5, and I'll cut it off there. So let's say that our frequency of people in the 4 to 4.5 range is 1, 4.5 to 5 is 2, in 5 to 5.5 we have 15, 5.5 to 6, 5, and 6 to 6.5 we have 0. So this is our frequency table. Now, using our frequency table, we can construct a histogram which displays graphically the same thing as the frequency table. So we'll draw an axis here and label the horizontal one with the different ranges for height that we had. And then I'll label the vertical axis. And so now if we recall, in the 4 to 4.5 range there was one student, so I'll draw a bar that goes up to 1 for that. In the 4.5 to 5 range there were 2 students. In the 5 to 5.5 there were 15, 5.5 to 6 there were 5, and 6 to 6.5, 0. So now we can see visually through our histogram that most of the students fell in the 5 to 5.5 range. There are several ways to classify the distribution patterns created by histograms. One is by discussing its symmetry. So a distribution can be symmetric. It can be skewed to the left, meaning that it has a very long tail at the left side, or it can be skewed to the right, meaning it has a long tail at the right side. We can also classify a distribution based on the number of modes it appears to have. So we can have a distribution that is unimodal, meaning it only has one mode, which is the case for all of these graphs that we've drawn so far. Or we could have a graph that is bimodal, meaning that there are 2 modes. And we see that each of the peaks corresponds to a mode. The normal distribution is a very special type of distribution pattern. It looks something like this, and people often say that it has a bell-shaped curve, or they call it a bell curve. It is always symmetric and unimodal. A normal distribution can be described by two parameters, the mean, or x bar, and the standard deviation, which I will represent with an S. So let's look at a picture of our normal curve. The point exactly in the center is the mean. And then we can go to the left or right and add standard deviations. So a point here would be the mean plus standard deviation, and a point on the opposite side would be a mean minus the standard deviation. We can go out further to the sides so that we're at the mean plus 2 times the standard deviation and 3 times the standard deviation. We can do the same on the opposite side. One important characteristic of normal distributions is that 68% of the population always falls within 1 standard deviation from the mean. And 95% fall within 2 standard deviations, and 99% is within 3 standard deviations. So now if we look at this distribution, we know that 68% of the population falls within these two scores. So what we can do is divide this into 2 sections, and since it's symmetric, we know that 34% of the population falls in these ranges respectively. Now we know that 95% of the total population falls in this entire range. If we subtract 68 from 95 and divide by 2, we end up with 13.5. So that's the percentage in this range here. We can do the same for these ranges, and that gives us 2% here, 2% here, and we're left with 0.5% on the ends.